everyone, we're going to find the area of the region bounded by the given curves y equals x times e to the power of negative x and y equals e to the power of negative 2 times x. Let's find our intersection points first because that's going to be our bounds. So we're going to set y equals to y, so we have x e to the power of negative x equals e to the power of negative 2 times x. And let's move everything over so we get x times e to the power of negative x minus e to the power of negative 2 times x equals 0. It looks like we can factor out an x. So you factor out an x, you get e to the power of negative x minus e to the power of negative 2 equals 0. So for this piece, we just get x equals 0. And for this piece, we get e to the power of negative x equals e to the power of negative 2. So all we have to do is look at this part right here, and we're going to get x equals 2. So this is our bounds. We're going to go from 0 to 2. You can graph this. This one's kind of hard to graph, or you can just look at if we're going between 0 and 2, pick a number in here, say 1, and what we're going to do is set x times e to the power of negative x is greater than or equal to 0, and e to the power of negative 2 times x is greater than or equal to 0, and see which one's bigger. Which one's bigger is going to determine how you subtract these. So for example, since we're going from 0 to 2, let's choose 1. If I let x equal 1, then I'm going to get 1 times e to the power of negative 1. That's going to be 1 divided by e. For this one, if I let x get 1, I get 1 divided by e squared. All right, so that would be, that's just it. So this one is smaller because my denominator is larger. So this means this one is larger, and I'm going to take this one, x times e to the power of negative x, and subtract this one. If you graphed it, you would see that this one is the upper part of the curve. So you can also look at it like this. It would be like something like this, and that would mean the upper part of the curve is this one. And then we'll do dx. Now let's split this up a little bit. Let's write this as the integral from 0 to 2 x e to the power of negative x dx plus the integral of 0 to 2 of negative e to the power of negative 2x. Now, I can go ahead and put this in front, but I want to deal with this this part a little later. Let's do this one first. So we're going to integrate this using the shortcut, and let's do that. So we're going to have the integral from 0 to 2, and that's x times e to the power of negative x dx. And we can use tabular integration on this versus integration by parts. That means we're going to take the derivative of our algebraic expression and integrate our exponential expression. So for the derivative, basically you just keep taking the derivative till we get to 1. So the derivative of x is 1, derivative of 1 is 0. So once you get to 0, you stop. Now let's integrate this one. This is going to be negative e to the power of negative x. Integrate it again, you get e to the power of negative x. Then you draw these lines, and this is going to be plus and minus. So basically when you write your integration, it's going to be, this one's plus, so it's negative x e to the power of negative x. And then we have a minus here, so it's minus e to the power of negative x. And then we're going to evaluate it from 0 to 2. This is going to give you equals negative 2 e to the power of negative 2 minus e to the power of negative 2 minus 0 minus e to the power of negative 0. So this is going to equal, since these are the same, that's negative 3 e to the power of negative 2, and this equals 1. Anything to the 0 power equals 1. So it's going to be plus 1. So that's the first part. And then what we had was we had this plus the integral from 0 to 2 of negative e to the power of negative 2 dx. Now I can rewrite this as negative e to the power of negative 2 because that's a constant times the integral of 0 to 2 of, whoops, where's my x? There was an x here. X dx. So basically what this one's going to do when you integrate this, let's integrate that one. You're going to get, let's see, the integral from 0 to 2 of x, and we also had this negative e to the power of negative 2. All right, dx. This is going to give me 1/2 x squared, and we're evaluating this from 0 to 2. This is times negative e to the power of negative 2. So when you substitute in 2, you're going to get 1/2 times 2 squared, and that's going to equal 2. So basically you're going to get, so let's multiply this by this, and you're going to get equals negative 2e to the power of negative 2. So the first one we got was negative 3e to the power of negative 2 plus 1, and then you just subtract that. Minus 2 times e to the power of negative 2. And this is your area. All right, let's see. These are the same, so I can fix this up. This is negative 5. Yeah, negative 5 e to the power of negative 2 plus 1. So this is better. Also, you could write this as negative 5 divided by e squared plus 1. It just depends on how far you want to simplify. Thank you. Have a nice day. Bye-bye.